How does reversibility affect Carnot cycle efficiency? Imagine a machine that runs so perfectly that it wastes no energy and makes the most of every bit of heat it takes in. That's what the idea of reversibility in thermodynamics is all about. When we talk about the Carnot cycle, it's like the gold standard for heat engines. It's a theoretical model that shows us the maximum efficiency possible. But what makes it so efficient? It all comes down to whether the processes inside are reversible or not. A reversible process is one that happens so slowly and smoothly that the system stays in equilibrium at every step. There's no friction, no turbulence, no unrestrained expansion or sudden heat transfer. Because of this, no energy is lost as waste heat or dissipated as entropy. In the Carnot cycle, all four stages, to isothermal processes, where temperature stays constant, and to adiabatic processes, where no heat is exchanged, are carried out reversibly. This perfect balance means the cycle can reach the highest possible efficiency. The efficiency of a Carnot cycle depends only on the temperatures of the hot and cold reservoirs. It is calculated by subtracting the ratio of the cold reservoir temperature from the hot reservoir temperature, divided by the hot reservoir temperature. If the hot reservoir is at a higher temperature and the cold reservoir is at a lower temperature, the efficiency gets closer to 100%. But this only holds true if all the processes are reversible. If any part of the cycle becomes irreversible, say heat transfer occurs with a finite temperature difference, or there is friction or rapid expansion, then some energy gets wasted. These irreversibilities generate entropy, which means the engine can't convert all the heat into useful work anymore. As a result, the efficiency drops below the ideal Carnot limit. In real engines, perfect reversibility is impossible. Friction, rapid heat transfer, and other factors always introduce some irreversibility. That's why actual efficiencies are always less than the Carnot efficiency. Still, the Carnot cycle gives us a benchmark, a goal to aim for when designing engines. It shows us that minimizing irreversibilities is key to getting closer to maximum efficiency. So, in simple terms, the more reversible the processes in the Carnot cycle, the higher the efficiency. Reversibility keeps entropy unchanged and allows the engine to operate at its best. Any irreversibility causes energy to be lost, reducing how well the engine can perform. That's why understanding reversibility helps us see why real engines can never reach 100% efficiency, but can get closer by reducing energy losses.